When we think about math, most of us picture classroom, right? Something we had to get through and then, well, we left it behind. But what if it's way more than that? What if math is actually a universal language? A language that can give us real power, real independence in our own lives. So let's dive in. And this, right here, is the heart of it. Let that sink in. 2 plus 2 is always going to equal 4. It doesn't matter if you're in the United States or the Navajo Nation. It's a truth that just is. It doesn't need anyone's permission, and it doesn't bend for authority. It's bedrock reality. Okay, so that's the big idea. But how does that actually work? I mean, how can something like algebra or statistics translate into real-world sovereignty? Well, the wild part is, it's already happening. It's built into the tools we use every single day. We're going to break down exactly how this works across 3 key areas. All right, first up, the algebra of secrets. This is where we get into the nuts and bolts of how math lets us own and control our digital lives. Everything from our bank accounts to our private messages. It's all about creating secrets that are, for all practical purposes, impossible for anyone else to break. Think back to high school algebra for a second. Most of the equations you learned were kind of like a two-way street, right? If you know y, you can pretty easily solve for x, and vice versa. But what if you could create a mathematical one-way street? That's the foundation of all modern security. See, it's really easy to take 2 giant prime numbers and multiply them together to get a new, even bigger number. But if I just give you that final huge number, trying to work backward to find the 2 original primes, yeah, that's incredibly difficult. This idea has a name. It's called a trapdoor function. And the analogy on the slide is just perfect. It's super easy to mix blue and yellow paint to get green. But trying to unmix the green back into pure blue and pure yellow, good luck with that. It's pretty much impossible. That mathematical one-way door is what keeps your digital life secure. And we are not talking about small numbers here. The keys that protect your private information are often 2048 bits long. The scale of that is just mind-bending. Trying to guess the prime factors of a number that big is such a monumental task that, as the source material puts it, the universe would probably end before a computer could find the answer. That, right there, is cryptographic hardness. So that's the secret sauce. This mathematical imbalance, this trapdoor, is what gives you the power to digitally sign a document or send an encrypted email and have it be provably, verifiably you. It's the math that lets you truly own your digital self. Okay, so algebra helps us own our digital identity. But what about the physical world around us? Well, that's where our second pillar, statistics, comes into play. By understanding the math of how things change over time, we get the power to verify reality for ourselves, so we don't have to just take someone else's word for it. Take something like radioactive decay. It follows this incredibly predictable pattern called a half-life. So if you start with 100 grams of something, after one half-life, you've got 50 grams left. After another half-life, you're down to 25, then 12 and a half. You see the pattern, right? It just keeps getting smaller and smaller, getting infinitely close to zero, but never actually reaching it. This curve is a mathematical law of our universe. And to put this into perspective, think about uranium-238. Its half-life is 4.5 billion years. That means that over the entire course of recorded human history, its danger has barely diminished at all. For you and me, that danger is permanent. And that's not an opinion. It's a verifiable fact thanks to the numbers. Now, here's where the real power kicks in. Math doesn't just describe the problem, it gives us the tools to solve it. Using a tool called logarithm, which basically acts like an undo button for this kind of exponential math, we can flip the equation around. Instead of just calculating decay, we can actually solve for t, for time. This lets us independently answer crucial questions like, when will this land be safe to live on again? So we've used math to own our digital identity and to verify physical reality. The final piece of the puzzle is understanding the tools that bridge those two worlds, our machines. Because let's face it, to be sovereign in this digital age, you need to understand their fundamental language. And at the absolute core of every computer is simple, undeniable mathematical logic. This sounds almost too simple to be true, but every video you watch, every app on your phone, every single line of code that makes the modern world run, it all boils down to billions of tiny little switches that are either on or off, true or false, 1 or 0. That's literally it. So how do you get these billions of switches to think? They follow incredibly simple rules laid out in what's called a truth table, like the one you see here for an AND gate. The rule is dead simple. The output is only 1, or true, if input A and input B are both 1. That's it. It's this tiny atomic decision, but it is the fundamental building block of all computer thought. When you combine millions and billions of these simple logic gates, you can build everything from a basic calculator all the way up to a powerful artificial intelligence. Once you understand this logical foundation, technology stops being a magic black box. It becomes something you could understand. And that understanding, that gives you power over it. All right, let's pull all three of these powerful mathematical pillars together. We've seen how algebra, statistics, and logic each give us a very different but equally essential tool for our own personal sovereignty. So you have the abstract algebra of trapdoor functions, which gives us true ownership of our digital selves. You have the statistics of exponential decay, giving us a way to independently verify the physical world. And you have the Boolean logic of circuits, which gives us a foundational understanding of the very tools that shape our reality. It's a complete toolkit. And this really is the ultimate takeaway. Math isn't just about solving for x in a textbook. It's about understanding the rules of the systems we live in, both digital and physical. When we grasp this universal language, we stop being just passive users of technology. We become its architects. We start to claim real ownership of our own future. So I'll just leave you with this question to chew on. If you look at your own world, your finances, your privacy, the tech you use every day, what part of it could you understand or verify or maybe even own just a little bit better if you learn to speak the universal language of mathematics?